So coming to the next adsorption isotherm, this is the second after the Friendlich adsorption isotherm, and it is called the Langmuir adsorption isotherm. And this is very important because this isotherm we usually use in our experiments and research and for the application of the for different application which involve the adsorption phenomenon. And this is the Langmuir adsorption isotherm. And this is the equation. Theta equal to Kp over Kp plus 1. K is the adsorption constant. P is the pressure. 1 is the constant, and theta is actually the value. It is also a fraction. I will talk about the theta. And actually, we will derive this equation later on. This is not the empirical equation. This is the theoretical equation having some experimental background. So we will derive this equation later on. First, we will look at the what is the adsorption, Langmuir adsorption isotherm and its assumption, and on which it is going to based on, and this we will discuss in today's lecture. The first, what is the objective of the Langmuir equation? And this is going to describe the equilibrium between the molecules in the gas phase and the molecules bound to the surface. Let's suppose this is the cylinder, and here what is happening over here? You have put some molecules which are in the gas phase, and this is the surface, and molecules are going to adsorb on the surface. So there is the equilibrium between the adsorbate and the adsorbent. So this we will explore in the coming slides. Let's suppose what we are going to do in the experiment in the same way you will perform in the lab as well. So we will introduce some molecules in this chamber and wait for the equilibrium. Equilibrium is important as we have discussed before. So there is the equilibrium if it is the physical adsorption equilibrium between the bonded and the unbonded, or the adsorb or the deadsorb molecules. So then the plot number of molecule adsorb versus equilibrium pressure that these are actually in the slides we will focus on these 3 points. The first starting, I'm going to start the experiment to verify the Langmuir adsorption isotherm. So let's suppose if it is without gas molecules, that means no gas molecules, and this is the again amount adsorbed, how much number of molecules are adsorbed, and what is the pressure of the gas. So we will first work on the pressure, and then we will replace this one with the concentration if you are using liquid as the adsorbate. So when there are no molecules of the gas, of course, the value over here will be zero. Zero pressure, no molecule, that means zero pressure, and if it is a zero pressure, no number of molecules are adsorbed. So we are going to start this adsorption isotherm. So the second, let's suppose you have introduced 4 molecules of the adsorbate. Right? अब 4 molecule adsorbate आपने add किया. Now what would be the next step? The equilibrium will establish with the 4 molecules. So with the 4 molecules, some molecules are going to adsorb and some molecules will remain in the gaseous phase. So what is happening next? Let's suppose with the 4 molecules, now 3 molecules are adsorbed and 1 molecule is in the gas phase. So there is the equilibrium. If the 4 molecules, the equilibrium between 3 and 1, 3 are now adsorbed and 1 is left, and equilibrium is established. So this is the point is indicating here. These are the 3 molecules which are adsorbed. So this graph is showing how many molecules are going to adsorb, because we are going to plot and adsorb the number of molecules adsorbed on the surface of the adsorbent, and this is the adsorbent. So the red colors are showing adsorb and this green is showing it is in the gaseous phase. So let's suppose what is happening next. Now you are introducing 8 number of molecules. So starting your experiment, you have introduced 8 number of molecules. How many adsorb? 6 adsorb and 2 are in the gaseous phase, which are unadsorbed. So what do you say the difference between the previous slide where 4 molecules were introduced, 3 were absorbed, 1 is left, and now you are introducing 8 molecules, 6 are adsorbed, 2 are left. Why they are left or 6 are absorbed? Because there is the equilibrium between the adsorb and the deadsorb. Let's suppose the third slide. If you are introducing 15 molecules, how many molecules are adsorbed? 9, and left are the 7, because total are the 15, and the arrow point is indicating is here. These are the 9 at 9. 9 molecules are adsorbed and 7 are left, and there is the equilibrium between the adsorbed and the unadsorbed molecules. So let's see another slide. You have introduced 24 molecules. Now equilibrium again established with the adsorption of the 10 molecules, and left 14 are left which are not adsorbed, that means in the gaseous phase. So actually what is happening, just look with the start with the 4. अब आप यहाँ पे conclusion आप देखें आप क्या feel कर रहे हैं, what is actually the isotherm is going on or the adsorption phenomena is going on. And this is the same way we have explained in the previous lecture. Actually, we are talking about the adsorption isotherm. And here particularly is the Langmuir adsorption isotherm, because the x and y axes are changed, but it is generally adsorption isotherm. So with the 4 molecules, 3 are adsorbed. With the 8, 6 are adsorbed. With the 15, 9 are absorbed, 7 are left. And with the 24, 10 are absorbed, 14 are left. So what is your conclusion over this when you are starting with the 4 molecules and ending with the 24 molecules? Adsorb burden and pressure is the limiting pressure is the limiting factor. How you said pressure is the limiting factor? एक और, what about the unadsorbed? 1 is left. Just compare between the adsorb and adsorb. Total molecule 4, more adsorb, less unadsorbed. ऐसे ही. Then with the 8 molecule, more adsorbed as compared to unadsorbed. ऐसे ही. With the 15 molecule, more adsorbed as compared to the unadsorbed. With the 24 molecules, now the case is opposite reverse. 10 adsorbed and 14 molecules are left. Why this? No, actually this is to discuss over here why this is happening at the start. Can you explain why now the process is the reverse? With the 24 molecules, less surface area is available. Less surface area is available, or all the occupied surface, all the empty pores are now occupied, and you can have a look over here. ये आपके पास जो है वो 10 adsorb है, and 10 adsorb. Now at the start, all pores were available, so the adsorption process was fast, and then it is going to incline because some of the pores are occupied, and then there is the decrease in pressure, and then after certain time there is no change in the molecule, because all the surfaces are now occupied by the adsorbed molecules, and this is the actually the adsorption, Langmuir adsorption isotherm is happening. Why this is going to be happen? Because there is the equilibrium between the adsorb and the अनएब्जॉर्ब मालिक्यूल। और ये डिपेंड करेगा क्योंकि स्टार्ट में आपके पास नहीं थे इसलिए ज़्यादा एब्जॉर्ब हो रहे हैं, लेकिन जैसे जैसे पोर्स ऑक्यूपाइड होना शुरू होंगे ये आपके पास कम हो जाएंगे, अनएब्जॉर्ब जो अमाउंट ज़्यादा होना शुरू हो जाएंगे। सही, लेट्स सी व्हाट इज नेक्स्ट. So this is actually the first is the theta. Theta here is the fraction adsorbed. So what is the fraction adsorbed? It is the number of adsorbed molecule and the maximum sites are available. So important here is to remember that this fraction, the maximum value of this fraction will be the 1. कैसे आपके पास, let's suppose the maximum available sites are 10. Then how many molecules are the maximum molecules may be absorbed? 10 ही हो सकते हैं, इससे ज्यादा हो नहीं सकते. 10 divided by 10? 1. Let's suppose if the maximum sites available are 100, how many molecules of the adsorbate can occupy these sites? 100. 100 divided by 100? 1. So that's why this is called the fraction. So fraction adsorbed, this is the adsorbed, this is the available. So that's why this theta is called the fraction adsorbed, and the maximum value would be 1. So it is starting from the 0 and ending with the 1. And in the similar way we have discussed in the Friendly adsorption system, वहाँ पे भी दो values को discuss किया था, 0 and 1. And similarly you can apply the same knowledge over here to discuss the fraction of adsorption, and this is the ratio between the number of adsorbed molecules with the maximum sites are available. Actually the upper one is n is belongs to the adsorbate and this belongs to the adsorbent, because the sites should be available with the adsorbent, and these are the number of molecules which are going to adsorb on the surface of the adsorbent, and that's why this is called the fraction, or you can say it is the ratio. So these are the basic assumptions for the Langmuir adsorption system, and we have explained in the previous slides. The first one is the adsorption sites are homogeneous and equivalent. This is the surface of the adsorbent, and these molecules are the adsorbate, maybe the pressure, maybe the liquid in case of the liquid, or gas in, you can consider the pressure. And what does it mean? These are the homogeneous, that mean are having on a same or equally important, all sides are equally important, there is no difference between one side to the other side. So molecule may be absorbed over here. If there is one molecule is going to absorb, it may be absorbed at this point, may be absorbed at this point, may be absorbed at this point, because all sides are the equivalent. There is no difference between the sides available. So that means there is equally, all sides are equally important, having the same intermolecular forces interaction between the adsorbate and the adsorbent. Clear hai ye point? Second, the adsorbed molecules are immobile and they do not interact. So that means they are not going to move. If it is adsorbed over here, it will adsorb at this point, and this molecule is not having interaction with the other molecules. It is only having interaction with the adsorbate and the surface, which is the adsorbent, not the interaction between the molecules which are adsorbed on the surface of the adsorbent. Clear? Now the third point is only monolayer coverage is possible, and if you have a look on this surface, this is the surface, and you can see there is only one layer of the molecules are adsorbed, because all, let's suppose these are the 4, there are 8, 12 or 16 sites are available, and 16 molecules of the adsorbate on the surface adsorb. So only one layer is possible. There is no chance for the second layer. So only monolayer adsorption phenomena is happening. These are the 3 main assumptions for the Langmuir adsorption isotherm. अब यहाँ ये दोनों के लिए अभी मैं आगे एक्सप्लेन करता हूँ. दिस मे बी बिकॉज व्हेन इट इज द मोनोलेयर, then it is the chemical adsorption as we have discussed earlier. So when it is the multi-layer, then it may be a possibility for the physical adsorption. So there, actually with some modification, actually we will discuss later on. Chemically we can also explain, physical we can also explain. So some of the points which are going to fit with the physical adsorption and some points which are going to fit with the chemical adsorption. So if you are considering a monolayer, of course you are right, it is the chemical adsorption, but monolayer adsorption may also be happen with the physical adsorption. Basically it is for the chemical adsorption, but you cannot neglect it is not applicable for the physical adsorption. If there is no further possibility to adsorb another layer depending on the molecules, because in the physical adsorption now these molecules are acting as the adsorbent. That means they can further adsorb. So there are both possibilities. If the molecules are such they can adsorb further, it is the physical adsorption. Otherwise, it will be a chemical adsorption. But we can consider the first layer as a monolayer for the both chemical and the physical adsorption. Clear? So this is again the first one equation. We actually the next we will drive this equation. This is the fraction adsorbed. K is the equilibrium constant and P is the equilibrium pressure. So equilibrium constant, and this is not the simple pressure. This is the pressure at equilibrium. That means you are these are the when the equilibrium is established. That's why I have shown you different slides to get this point. This is not the only the pressure, but when you add the molecules in the container, the equilibrium is established. And after the establishment of the equilibrium, this is called the equilibrium pressure. So you have to use the equilibrium pressure against the fraction adsorbed, which is called the theta. So this is the same. So this is the graph again with the actually, this is the same graph. It is the adsorption system. Pressure was theta. When you plot, it's starting from the zero sharp line because all surfaces are sides are available. Then bending, and then it will remain constant. Further, if you increase the pressure, this is not going to change because the fraction will always be maximum 1. After 1, if you increase the pressure, this is not going to disturb the fraction which is going to adsorb because all surfaces are now occupied. These are the similar to the Freundlich adsorption isotherm. We discussed 3 points there. Here also it is very important because you can modify the equation or you can use this equation to satisfy the position on the graph. So the first one is like this. Here you can see it is the straight line passing through the origin. That means x-axis is directly proportional to the y-axis. That's why you can find here is the straight line. The more is the equilibrium pressure, more will be the fraction adsorbed. As in the starting, in the 3 slides we discussed when we introduce 4 molecules, 8 molecules and the 15 molecule. So more you are going to introduce, more will be the fraction adsorbed at the end. And what is the condition over here? This is actually when the pressure is, it is the 0. When pressure is 0, so if you put the pressure over here, 0 multiplied by this, the whole equation will become 0. So that means when the pressure is 0, theta will be 0. So this is at this point. So when pressure is 0, theta will also be 0. Now it is going to start with passing through the origin. And then what is the limiting or the final or the last value? When the pressure will be infinity. यही हो सकता है ना, maximum pressure. Infinity means the maximum pressure which is required for all the molecules of the adsorbate adsorb on the surface of the adsorbent. ऐसे ही होगा. When this is the pressure will be the infinity, then this theta will be 1 as we have discussed before, because theta is the fraction of the ratio between the adsorb and the available sides. So this will come when there is the maximum pressure, and this is shown over here. When it is, this is the maximum pressure, let's suppose 14. And at this point, what is the value of the theta? This is the 1. These are the two conditions, and in between, actually similar to the Freundlich, you can follow this equation in between 0 and 1. This is the, it depends on how much pressure or you are using and what are the available sites for the molecule. Again, it is written over here, the same formula for this. It is the fraction adsorbed, that means number of molecules adsorbed and the maximum sites available. And this will remain, the maximum value will be 1. So these actually we have discussed. I am ending with this slide. Actually, I have introduced two more points which we have discussed before. Assumption of the Langmuir adsorption system. The first one is adsorption cannot proceed beyond monolayer. Say this you have asked. That means if this is happening, it may be a chemical adsorption. Ca is the chemical adsorption. The adsorption cannot proceed beyond the monolayer. So only the monolayer is possible. That means it is the physical adsorption. Chemical adsorption. So second is the solid surface, which is the adsorbent, is homogeneous, having fixed number of the adsorption sites. So there should be a fixed number of adsorption site, and it should be a homogeneous. That means all sites are equally important or equally applicable for all the molecules of the adsorbate to adsorb on their surfaces. Clear again? Third point, each site cannot adsorb more than one molecule. So because this is the phenomena for the monolayer, each site is available for the each molecule. So there should be a equilibrium between the adsorption, and we call it when the gas is adsorbed, that process is called the condensation. It will become in the liquid because more interaction between the adsorbate and the adsorbate and between the desorption. So simply there is the equilibrium between the adsorption and the desorption. So when you considering the equilibrium, actually this is the process for the physical adsorption. So that's why I have discussed earlier. This Langmuir adsorption we can apply in both physical and the chemical adsorption. But if it is happening with the physical adsorption, then it is only the monolayer we are going to consider. It does not mean monolayer just only belong to the chemical adsorption. So these are the assumptions we can fit on all the data available. Number 4, no interaction between the adsorbed molecule. Ability of the molecule to adsorb at a given site is independent of the occupation of the neighboring sites, because and this property is actually for the chemical adsorption, because they are chemically bond between the adsorbate and the adsorbent. It doesn't going to interact with the rest of the molecules. So this property, actually all these differences we have already discussed when we discussed the difference between the physical and the chemical adsorption. And the last one is the adsorbent surface is uniform energetically, and this is actually the same point I will discuss in the first one. It is the homogeneous. When it is the homogeneous, that means it will be energetically equivalent, uniform, because having the same energy or the same release of energy when the molecules of the adsorbate are adsorbed on the surface of the adsorbate. So this is all about today's lecture.